Hello, everyone. First of all, thank you for coming to see my talk. I think the title is pretty self-explanatory, so let's start this. I'd like to give some context of what I'm going to cover in this talk. First, I'm going to give a small overview of what Ecto is and what it gives us. Then talk a bit about how you can extend Ecto and what is the contract that you have to follow when you're doing that. Finally, what do you get without SQL with Ecto? I'm going to give some examples of that, and that's it. And before I start, I'd like to talk just a bit about myself and my context. I go by Nirev on most of the internets, so you can find me there, especially Twitter. I'm based in São Paulo, Brazil. I've been using Elixir as my primary language since 2015. Before that, I was doing mostly Java, C, embedded code, media applications. And then I joined a startup there in 2015 and started using Elixir, and I'm in love since then. I've been a regular at the São Paulo Elixir meetups, and in the past year, I've been co-organizing that with Renan, who's also here. We have almost monthly meetups, around 50 people each. The largest one we had was over 70, which is pretty awesome. And we do have a pretty active Brazilian Elixir group on Telegram. We just passed the 900 members mark a couple of days ago, so I'm really excited to get over 1,000. That's cool. I work for Telnyx, which is a communications platform as a service. It's a company based in Chicago, and they're sponsoring my visit to ElixirConf this year, so thanks. Telnyx is, like I said, a communication platform as a service, and it's not just like an average telecom company. It's kind of works in a different way. They're registered as a carrier in almost 20 countries, and besides that, we have our own network, with different points of presence all over North America, Europe, Asia, soon South America, São Paulo, I hope. And all those points of presence are connected by fiber backbone. So all those green points are points of presence, and we have fiber backbone between them, and the blue ones are planned. So Telnyx has full control of the network, so we can get control of media packets, reduce latency, jitter, so we can have better quality over voice calls, and also SMS. And since it's a carrier, it can negotiate better deals and deliver calls with the local. So if you place a call from Sydney to Chicago, you do a local call there, then it travels through the Telnyx network, which has better latency for media packets, and then it connects to a local call on the other side. And since I joined Telnyx, the product I've been working on is call control, which is about controlling calls via APIs. So basically, we process events from the telephony engine. We turn that into webhooks that we send to customers. Customers receive that and then can interact with the calls via API. So play some audio, transfer the call, dial new calls, and stuff like that. This product is almost exclusively written in Elixir, which is awesome, and you're hiring. So that's it. So, let's start. So what is Ecto? And I think to explain that, I'd like to first see how Ecto presents itself. So, up to version 2.q, if you went to Ecto's GitHub and you read the first phrase on the README, it said that Ecto is a domain-specific language for writing queries and interacting with databases in Elixir. So you can notice that there's a lot of emphasis on the database parts of things. So it's quite common for Ecto to just be Elixir database library. And I said that also in the past. And then people ask, oh, so is it like Active Record? Or you mean, is that an ORM? And Ecto is not really that, especially in ORM, because it's not object-oriented. And so I think that's part of why we had it changed. And now, if you go to Ecto's GitHub and you look at that very first phrase, the one-line summary, it now says that Ecto is a toolkit for data mapping and language-integrated query for Elixir. And I think that's part of an effort to show that Ecto is not just about database. It is a toolkit, so it has many parts that do different things. And I like to show what are those parts. So this is a small example. So basically, I want to create a database for a book where the title is Last Man in Europe. I want to get the record and then update the title to be 1984 and update it. So if you look at that, well, let's start with the book. Book is an Ecto schema. And schema in Ecto is the way that you define the shape of your data. So the Ecto documentation says schemas are used to map any data source into an Elixir struct. And the way you do that is by using Ecto schema, you get a bunch of macros that are back that help you build a data structure that represents your data. So in this case, defining the book, by using this schema, I'm telling like what is the database table, in this case, that holds a schema, in case books, and I can add fields like title, give it a type, use a string, and I can also do associations like many-to-many, and I can have authors, which is a book author that will have a different schema, and in this specific case, I'm telling which table I'm going to use for the many-to-many relationship. And like I said, those macros, they help you build a data structure that represents everything. So all that macros are doing is creating this struct. So if you take a book and you inspect it and look at what it has, what Ecto schema is adding is this meta field, which is the metadata, which tells Ecto what is the schema that was used to build this structure, what is the source, what is the state. This structure might have been loaded from the database, it might have been just created. Then for the fields, when it's an association, you can have the association, or in this case, it's not loaded, so you have just also metadata telling Ecto what is it. Right? And besides that, it also generates some functions. So if you go back to the book module, you have the schema function, and you can get what are the fields defining that schema, and also look into what are the types defined for those fields. So that's what schema does. Then we have the Ecto query. And I think query is exactly what you would expect, is a way to write a query in Elixir to retrieve information from repository, from a database. I think the main thing that they help with is avoiding SQL injection. So they have and also a nicer syntax because it feels Elixir. Have both a macro and keyword syntax. And like the schema, what it is, it generates a data structure that represents the query. So if you inspect that, the from, be, that's actually an Ecto query structure that represents the query that you're going to make. The other two is Ecto Changeset, which is, in my opinion, the most powerful thing in Ecto. Love it. So Changeset is a way of encoding, validating, and tracking changes to your data, right? So back to the book example, you could have, like, with Changeset, you cast parameters. So parameters can be an external source of the data, and you choose which fields you're going to cast from that. So it's going to look into the schema and check what is the type for those fields, cast it, and then you can perform validation, such as the validate required. You can implement your own validations for a book. You can validate the ISBN, or this is the dumb one, but just an example, like books can have no more than 42 letters. maybe that's it. And when you go through that, also what you have is a data structure that represents your data and the changes. So if you look at what a changeset has, it has the original data that you use to create that. And then it also has the changes. So if you try to create a change set for a book and the title may be too long for this validator, the change is there. So if you look at the data, it's empty and you have the new title. And since I added that dump validator, I also get the errors. So, it's structured in such a way that you can build the error message. So that field title should be at most 42 characters. So that's it. And then you also get like the current state. So if you go through all the validations and they do not pass, it's not going to be valid. And if they do, then it's going to be valid. Well, there's not just that it's in a change set. There are other stuff, but I'm not going to go through that. But just to show that the change set is a structure, like what schema represents, and to represent your data in the changes to your data. So it has everything that actually we need to then apply those changes and do all those errors, validations, and stuff like that. And finally, you have the Ecto repository, which I think is pretty straightforward. It's a way to access the repository, so you can perform the queries. So you can get all of the results. You can get one, you can insert, you can update, you can have transactions. So that's it. So far, what is Ecto is a data toolkit and library. Its main tools are the schema, changeset, repository, and query. And it's not an ORM, but it contains a mapper, which is the schema, and changeset, we can map data to a struct. Right. So, moving on to composability and extensibility, or what are the boundaries? So, first, like how all of those tools are tied together, and I tried to come up with a visual explanation of that. I hope it's useful, but what it is this: like you have external data, you pass that through a change set. Through the change set, you get Elixir data. The change set looks at the schema to know, well, what are the types of fields you have. If you have a query and you run that through a repo, your query will also reference the schema. So repository will check the schema to when retrieving results and cast that and return you Elixir data. So it's kind of like schema is the thing that actually does the type definitions for what you're querying or storing. And the changeset, repository, and query, they all use those type definitions, so everything can be Elixir data structures. And those type definitions are actually a behavior. So Ecto type is one of those extension points. Ecto type is a behavior for defining new types. And so you can map external data to your Elixir data. And there are the four main callbacks that you have to implement. So type is to tell the adapter what is the Elixir type that you expect from that. Cast is when you're casting data. For example, with Ecto changeset cast. So you can take what is usually a string that you get from the external source and parse it and generate some Elixir struct. You can also cast within a query without the changeset, but that's not that as used as changeset cast. Then dump is to transform the Elixir struct into what the repository expects. So, for example, when doing repo insert. And then load is the other way, when you're reading from the repository and you want to transform that information into your Elixir struct. So that's it. This is an example I took from code, like an Ecto type for a phone number. So define a struct that has a number, type would be a string, and cast then is taking external data. So and the interesting thing here is that you can use pattern match. It's kind of like a possible law. You be conservative in what you send. You're always going to build an Elixir data structure, but you can accept different formats in different ways, and you can parse that and transform the same thing. So I can get a phone that is a string, and then I can parse it and build a module that has a number. Or I can just, I can receive a module that was, a structure was previously built, so it's already parsed, so I just take that. And then a dump, it's the same thing. I have that, my Elixir structure. I just need to transform that into data that goes to the database. So it's the string, and when loading, I get the string from the database, and I transform that into my Elixir struct. Right? So going back to that, how everything ties together, and then in the repository, you could have different storage. You could go to Postgres, you can go to MySQL, you could go to whatever. So how do you do that? And the answers are adapters. Like, Ecto is shipped with a lot of adapters, a set, I think it's 5. And, well, they're there so you can adapt Ecto to work with other storage and databases. So you define how to execute queries against it, because queries are data structure. So you use the adapter to transform that query, that data structure, into the actual query that you're going to send to your storage. And also how to map the Elixir types to storage, like how do you store an Elixir map? If you go to Postgres, it's JSONB. If you go to others, it's going to be a different thing. So, and also handle transactions, migrations, and etc. And then also composing things, like both extending Ecto and composing. And everything is data, like the schema is the data structure, query is the data structure, the Changesets is the data structure. So everything's composable. And why is that good? Like, so if you have a query, you can have a base query, and then you can use different functions to augment it and to or to filter it. So you can have the query and use roles in the different modules that just filters for admin. You can preload address. You can filter by country. When you have a changeset, you can start with changeset for the book, and then you can have stuff in the publisher module. You can do a ESBN validation, might be something big, and you do it in different modules. So what you get with this, of everything being a data structure, is that you can pass it through functions and modify it, and you get the same data structure. And again, why is that good? It gives us separation of concerns and reusability. You can extract that common stuff to some other modules that you can then test in separation. You can use whatever as you want. And yeah, so it's basically the extensibility and composability of Ecto. I needed that. Okay. So then, now that I explained like the building blocks, what is Ecto without SQL? What do you get from that? And in my view, like when I'm thinking about Ecto without SQL, there are two possible ways to do that. One is like storing data in non-SQL database or things, and the other would be using Changesets and schemas for data validation and mapping, but not storing or retrieving that. So, start with Repo without SQL. Like the how, it's easy. Ecto already provides us all the adapters. So there's nothing preventing you from implementing those adapters to stuff that are not an SQL database. And well, you could, I don't know, save those tracks as a file, and then you can retrieve from file. And, well, in fact, I went to Hacks and GitHub, and I was searching for different adapters, and I found quite well, not a lot, but some examples. Like you have, for example, the DynamoDB adapter, and that is a key value store. There. Then you have Ecto LDAP, ETF-wise, and that one I think is pretty interesting because, I mean, I never thought about like querying LDAP with SQL, so it's okay. Then we have MongoDB Ecto, which maybe official or semi-official, and well, it's not SQL. And actually, in MongoDB Ecto, it was the reason some stuff appeared in Ecto later. Then I also found this old, I think it's 3 years old, test of implementing Ecto adapter for ETS, so you could have an in-memory database, and also retain DB. So it can definitely be done, and if you want to look at one of those, I recommend looking at Ecto LDAP because it's the most different one, and it's pretty fun to see the adapter implementation. Okay, but besides there being those examples, well, there's a caveat, is because current Ecto query is very SQL-centric. So you got all those macros and the syntax for doing SQL joins, for transactions, for selecting, for doing aggregation, stuff like that. So it feels very SQL-y. But you don't need to implement all of the adapter callbacks. Like if your storage doesn't support transactions, you don't need to implement that. And not even that. I mean, if there's an operation from a query that you don't really support, you can implement the callback. But if the query has an operation that you don't support, you can raise. So that way, when someone is working with your adapter and they're doing development, if they use that operation, they'll see the raise, and with a nice error message, they'll know that it's not supported. But, well, it feels a bit strange. So perhaps if you're trying to use Ecto for that, one thing that you could try, and I think that's worth doing, would be to create a new query for Ecto. Maybe for graph database, I think it's different, so you could perhaps have Ecto graph query or something like that, which would be cool. But that's all to say on how to work with repositories that are not SQL. I think the most interesting part would be Changesets without the repository. I think that's where the biggest value would be extracted. So the idea here is to use Changesets for what they do best, which is data mapping and validation while avoiding going to the database. So if you look back at that book example that's defining the schema, see the schema books is telling us what is the table where that schema is stored. And the many-to-many relation, if there's a join through option with book authors, in which is telling us the table that is used to do the join. So there is a lot of database stuff that is coupled with that. So if you want to use Changesets without it, it has to be another way, which is the embedded schema. And this is something that came from the MongoDB adapter, if I'm not mistaken. So embedded schema is something that you can embed into other schemas. For example, if you have an embedded schema in a Postgres schema, then that would be just a JSON-B field, so you can define the schema for a JSON-B field. But for Mongo, for example, that's just that. You take the schema and you store it in Mongo. And if you want to use a Changeset without a repository, that's that. The embedded schema would just live in your application to be in memory. Right? So it doesn't require the source name and doesn't include metadata field. And in the case of many-to-many, since there's not going to be a relation, you can use embeds many, and that will create a list, and you can point to the schema in another place. So there's this nice example, the user registration example, that I took from the What's New in Ecto 2.1 book, which is a pretty good ebook by Plataforma Tech. So I just copied it because it's a great example. So you can define this module registration. The idea of that is to have a schema for your sign-up form. So imagine you have the sign-up, and you need to have a first name, a last name, and an email. And that's it. So you can define that embedded schema, then go through Changeset, define which fields you want to do that, you cast, and then you validate. So you can write your validations for your user form. And then instead of doing Repo insert or stuff like that, you can check if that change set is valid. If it is, you can apply the change set changes and get your data structure with those changes applied and then perform whatever operation you want. And if not, you can update a change set and propagate that to your view. So that change set apply change is something that works. Like we saw that the change set has everything regarding your data and the changes that you want to do with that. So it has data and it has changes. And when you do apply, that's just that. It's taking the changes, applying that to the initial data that you created change set with, and returning that data structure with the change applied. And that's it. So the next example is something that I took from my code base, validating requests. So in that call control product, we have a lot of different commands that customers can perform. They can answer a call, they can dial new calls, they can transfer, playback, whatever. And we need to validate the parameters before command execution. So in our case, we're not going to store or retrieve anything. We're getting parameters from customers, and we want to execute a command with those. But we need to validate. So I took the simplest one, which is answer. For answer, you need just the call ID that's in the path. And when answering, you can set the client state, which is we validate the format. So we created this validator module. You have the schema is a list of fields and the type definition, and it's using that API web validator. I'm going to show that next, passing the schema. And then back to the composability of stuff. In this case, the client state is something that we add to all of the commands. So that the validation of that, because we always check if it's a base 64 string, is in the different modules. So we can just use that in all of those validators. So in this case, it's pretty simple. I just start change set, I cast the parameters, I call the other validator, and that's it. The main of it is in that use validator. That actually is a plug. So when you execute that, the plug with the call, what we do is we build the change set from the connection parameters. So we are starting the change set with those params. And that's nice, because if there's an error, all we have to do is send that change set with all the errors to our view, and it's a structured format, so we can just report that, and that didn't came from any database or validation. It's just like we perform validation on what users submitted, so we can show nice error message for them. And if the change set is valid, what we're doing here is we created a data structure to wrap those command parameters. So we have the original params, we have the parsed ones, and a bunch of other stuff, and we change the connection parameters for that. So then when we get to the controller, it's actually very small because we use that answer validator plug. And when implementing the function, instead of getting the user parameters, we have a structured thing. We have the context. And then it's pretty easy for us to execute it because we can just execute the answer command using that command context. So for us, that was a big win. Like once we did that, what we got was consistent error handling for all of those actions. And we also got simpler code, like the validation was uniform and it was done closer to the parameters and to the controller as possible. And also it made the controller really simple and more testable because of the separation of concerns. Because if you want, when we test the controller, all we need to do is generate a context and pass that to the function. And when testing the validator, I can just test passing user parameters and then testing the chain set. So all those tests were really short and more concise. So, and then, well, some other considerations with chain sets without repo. Like, I showed one example that it fit our context of validating that, but the way I picture a system is that you can have external data, external things everywhere. You can have calls to your API in that external data. You can have an API client, and you don't really control that external API. You can change the response format. It can maybe introduce a bug, and you don't have control of that. You can depend on another service that's using a message queue and posting messages, so you're actually getting external messages. So you do need to validate that. Like I said about postal law, you have to expect those formats. They can appear in different ways, but you have to have a consistent way so you don't make your internal APIs uglier to deal with different formats for external data. So validating and mapping, like you have to validate and map that to your internal structures. But in doing that, you have to create like schemas for everything. Like you have one data format coming from an API, create a new schema, then you have to create a message, and then there's a schema, and then there's a new type of message, and suddenly you have 1,000 modules and just for creating schemas. No, you don't. Like besides chain sets without using the repository, you also have schemaless chain sets. So like I said, the schemas are just the type definitions. When you can have like inline type definitions as well. A chain set accepts that syntax. You can have the data and the type definitions, and you can create the chain set like on the fly. So you could create just those validation modules with the type definition in that, and it wouldn't create a lot of new structs and modules for that. Just, I think, pretty cool. Well, I didn't mention, what about the Ecto Split that was recently made? Like, that was a bit controversial at the time, but it's actually pretty simple. The Ecto Split is that all of those tools, the toolkit is in Ecto. So you have the schema, repository, chain set, create, there's mode, and the adapters, the extensibility part, all the API surface is in Ecto. And Ecto SQL is just the adapter implementation for SQL databases. So and that's it. I think controversial stuff is that people had to add the new line, the Ecto SQL, so it would continue working the way it was. And there was some controversy about the repository, like why is the repository not in Ecto SQL and still in the Ecto? And well, the reason is that the repository is agnostic. It doesn't have to be SQL. And the chain set, and I think mostly chain set has a dependency on the repository because the chain set also has to parse errors from the repository. But that was it. And I think the bottom line of that I'm going to say is that Ecto is a data toolbox. It's not a database toolbox. It's data. So, and the thing is that your data is not always persistent. And, well, when working with functional programming, data is the important thing. You're just passing data, changing data, functions. So you have to take care of that. And Ecto does not impose on you. So it gives us a lot of tools, and you have to use the tool to fit your context. So it's about, as a friend of mine like says, it's about massaging your data to fit your context. And so Ecto is kind of like a data masseuse. It's just doing that. And yeah, that's what I had to say. So, obrigado. And that's it.
All right, great talk. We have time for a few questions.
Hi, can you imagine using Ecto for validating CSV imports?
Okay, so you're asking about using Ecto to validate a CSV file. I don't think it would fit so well, because perhaps it would make more sense to use a CSV file as the storage layer, so implementing an Ecto adapter to saves and retrieve from a CSV. But the other way around, for getting CSV as external data, I think, because you could implement an Ecto type for that, but I think it would be too complicated to represent. So, but you could do that. You can take the CSV and wrap the CSV library inside your Ecto type, and then use that to generate a struct. But when doing that, I think what you do is implement the cast, but then the load and dump, I don't envision how that would work, like getting the struct, which would probably be like a header definition and then a bunch of rows. And when going to the database, I think they will probably map to a lot of rows and not just a single record. So I think that's how I picture that. I don't know if it would make much sense to use Ecto for validating the CSV. But maybe because I think the other thing is that when casting, you won't really get the nice error message for every field, because when mapping the CSV, you would get that whole thing passed through cast and can be the structure, which has header in all the rows. But if you want to have the error message, like some row has invalid data, then you would have to parse the CSV file first, and then use Ecto to validate each line, perhaps.
Other questions? All right. Let's give another round of applause to...
Okay. Thank you.